क्विज है आप लोगों का 27 को, नोटिस LMS पे डाल दिया गया है, लिंक जिस लिंक को ज्वाइन करना होगा आपको क्विज के लिए वो भी वहां पे डाल दिया जाएगा, प्लीज उसको चेक करते रहिए। एंड आई कैन नॉट स्ट्रेस एनफ ऑन द पॉइंट दैट यू हैव टू लॉग इन यूजिंग योर थापर आईडी। अगर आप थापर आईडी से लॉग्ड इन नहीं है, फॉर एग्जाम्पल अगर आप अपने जीमेल में लैपटॉप में इफ यू आर नॉट लॉग्ड इन विद थापर आईडी, यू वुड नॉट बी एबल टू एक्सेस द क्विज। लास्ट सेमेस्टर बहुत सारे बच्चों का इस चक्कर में क्विज है, दे मिस देयर क्विज। सो प्लीज मेक श्योर दैट यू लॉग इन यूजिंग योर थापर ईमेल एड्रेसेस ओनली। आप अपने पर्सनल जीमेल से लॉग इन नहीं कर पाएंगे एंड यू वोंट बी एबल टू अटेम्प्ट द क्विज इन दैट केस। Okay, let's start the class now. So in the last class, we were talking about the single slit diffraction pattern. I'll go through it quickly. We said that we have a slit and the width of the slit is given by B. You had a plano convex lens and then you had the screen over here. The light will be diffracted here and let's say at the point P, you are trying to see the intensity. And that's the angle of diffraction is basically theta at this point. Then we said that at point P, the resultant disturbances would be given by this expression. That E would be able to NA sine beta over beta cosine of omega t minus beta, where beta is nothing but pi over lambda into B sine theta. Lambda, wavelength of the incident light known to you. B is the width of the slit known to you. Theta is the angle of the diffraction. आपका angle of diffraction will decide कि आपके point P पे आपकी intensity का क्या होगा, whether you will be getting a minimum intensity or a maximum intensity at the point P here. So this was where we stopped in the last class. In this expression, the first term here, this, let's first deal with even the smaller term. NA is, N was the number of points, right? हर एक point पे we divided this slit into N number of points. A was the amplitude of the disturbances starting from each point. A1 से आपका A cos omega t हो रहा था, A2 से A cos omega t minus some phase constant जो हमने define किया था as phi. A3 से it was A cos omega t minus 2 phi and so on. So this A is the amplitude of the disturbances which were starting from each one of the point, which is constant. N was the number of points that you have defined. So we can just put it equal to some another constant so that I don't have to write two expressions continuously here. And then I can say that E is basically equal to A sine beta over beta into cosine of omega t minus beta. The first term here does not have any time dependence. This corresponds to your amplitude. The second term here, this corresponds to the phase. Beta is the phase constant, of course, right? At point P, jahan pe, where you observe the minimum or maximum, that corresponds to intensity. आप amplitude, for example, electromagnetic wave की अगर हम बात कर रहे हैं, यहाँ पे आपकी जो light incident होगी, that is going to be an electromagnetic wave, whether it's red, blue, orange, purple, whatever is the light there. In the electromagnetic wave, you cannot measure the amplitude of electric field or the amplitude of magnetic field. What you observe on the screen at point P is basically the intensity. And we know that intensity is directly proportional to amplitude square. So in that case, if intensity is directly proportional to amplitude square, we can say that I is equal to A square sine square beta over beta square. I can also call this as I naught sine square beta over beta square, where I naught corresponds to your intensity when your theta becomes equal to 0, or I naught corresponds to the intensity of the central maximum. The reason is that when your theta tends to 0, your sine beta will become equal to beta, and then you have beta square upon beta square, which will cancel each other out. Your I would become equal to I naught in that case, which would correspond to your intensity of the central maximum. So this, and then of course here if I'm writing I naught for a square, that means I naught is basically equal to a square. This is what I'm saying in this case. Now we would like to know at what points on this screen, at this point, this point, this point, or this point, we can expect a minimum, and at what points we can expect a maximum. If you look at this expression here, where we are saying that now your I is equal to I naught sine square beta over beta square, where we have defined beta is equal to pi O by lambda into b sine theta. This is the value of beta that we have defined previously. Now we would like to know the condition of minimum and maximum again. Let's first talk about the minimum, which is easier. Look at this expression here. I naught is the constant. If I want I to be 0, if you want I to be 0, that means what you would like is that your sine beta is equal to 0. But simultaneously, your beta should not equal to be 0. So you would like your sine beta to be 0, but beta should not be equal to 0. क्योंकि अगर आपका बीटा भी 0 हो गया और साइन बीटा भी 0 हो गया, 0/0 हो जाएगा, which would correspond to indeterminate quantity. And the condition when your beta is equal to 0 corresponds to your central maxima. क्योंकि आपका बीटा 0 होगा, that means you are saying your theta is equal to 0 in that case. And when your theta would tend to 0, in that case, let me repeat that again, whenever, and let me make a separate box for that. Whenever your beta would tend to 0, your sine beta would tend to beta, and your I would become equal to I naught. क्योंकि आपके पास में I naught बीटा स्क्वायर अपॉन बीटा स्क्वायर बच जाएगा, बीटा स्क्वायर से बीटा स्क्वायर कैंसिल हो जाएगा, your I would become I naught, which would correspond to the maximum intensity or intensity of the central maxima. So apart from that, if we want to have the minimum intensity, आपका numerator 0 होना चाहिए, but denominator should not be equal to 0 simultaneously. Otherwise, this would become an indeterminate quantity. So that means what I want is that beta should be equal to m pi, but m should not be equal to 0. क्योंकि अगर आपका m 0 हो गया, then you are saying beta is equal to 0, but we just said that we don't want beta to be equal to 0. So that means your m cannot be 0, or in other words, you can say that m can take any value 1, 2, 3, 4, and so on. When beta is equal to pi, sine beta is equal to 0. Look at this expression of intensity. When beta is pi, in the denominator you will have pi square, in the numerator you will have sine pi, which would basically be equal to 0. When beta becomes 2 pi, again your numerator is 0, but your denominator is a non-zero number. So as long as beta is not equal to 0 and sine beta is equal to 0, your I would be equal to 0 in that case. So we are saying that your beta has to be equal to m pi. Plug in the value of beta, because we would like to finally know at what value of theta we can expect the minimum and at what value of theta we can expect the maximum. So here, if you plug in the value of beta, which is given by this expression, pi over lambda b sine theta is equal to m pi, where your m is equal to 1, 2, 3, and so on. Pi से आपका pi cancel हो गया. B sine theta is equal to m lambda, where your m is equal to 1, 2, 3, and so on. From here, a couple of points to notice here. Here, this means that your sine theta is equal to m lambda over b. अगर आपका यहाँ पे सेंट्रल मैक्सिमा आ गया है, उसके बाद में आपका जो फर्स्ट मिनिमम आएगा, if you plot it as a function of theta, where would you expect that? When your m is equal to 1, your m is equal to 1, that means you can have this lambda over b. So whenever your theta becomes equal to sine inverse lambda over b, whether it's on this side or this side, आपका फर्स्ट मिनिमम आ जाएगा. सेकेंड मिनिमम की अगर आप बात करते हो तो आपका जो सेकेंड मिनिमम आएगा, दिस वुड बी योर फर्स्ट मिनिमम. सेकेंड मिनिमम would be when your m becomes equal to 2. So that means your sine theta is equal to 2 times lambda over b. At that point, you would expect your second minimum. This would be at sine inverse 2 lambda over b. And similarly, symmetrically on this side also, you will have the next minimum at this point. You know, with respect to center, where is your first minimum on this side? Where is your first minimum on this side? You can calculate the width of this central maxima. इस central maxima की कितनी width होगी वो आप calculate यहाँ से कर सकते हो. That was the one thing. The second thing is that how many minima you should expect. कितने minima आप expect करोगे? Do you expect an infinite number of minima? Do you expect 2 minimas? Do you expect 4 minimas? Or do you expect 10 minimas? That would be defined by this condition here. You know what is the maximum value of sine theta? The maximum value of sine theta could be equal to 1. Now, if you look at this expression, that means you can have 1 is equal to m times lambda over b. If you plug in the maximum value of sine theta, so that means your m could be b over lambda. This is the maximum order that you could expect. इससे ज्यादा मिनिमा आपको स्क्रीन पे नहीं दिखाई देंगे क्योंकि आपकी साइन थीटा की जो मैक्सिमम वैल्यू है वो 1 हो सकती है. m आप कितने m basically tells you how many minima do you expect. Do you expect 1 minima? Do you expect 10 minima? Or do you expect 100 minima? And that is basically going to be decided by this number here, where b is the width of the slit, lambda is the wavelength of the incident light. आप इन दोनों की रेशियो कैलकुलेट कीजिए and depending on that you can have just probably 1 minima, you can have 10 minima or you can have 20 minima. इन दोनों का जो रेशियो आएगा वो डिसाइड करेगा. So this was your condition of minima for a single slit. Now we are going to talk about the condition of maxima. Similar to this, we did find out at what value of theta you should be expecting your minimas, where you should expect your first minima, second minima, and third minima. Similar to that, what about the maxima? We did talk about the central maxima. कि central maxima तो आपका decide हो गया. You will get the central maxima when your theta is equal to 0 basically. What about the other maximas? Where can we expect this first maxima? Or where can we expect the second maxima and so on? So for that, if we want to get the maximas, your intensity expression is given by this, where beta is nothing but pi over lambda into b sine theta. If you want to get the maximum intensity, this is constant. You would like this term to be maximum. Now here is the problem. Minimum it was like comparatively easier. कि आपने कहा कि आपका denominator should be non-zero, numerator should be 0. Here, because both numerator and denominator are functions of beta, right? तो अगर आप इस पूरी की पूरी टर्म को मैक्सिमम चाहते हो, you would like your numerator to be maximum and denominator to be minimum. यही चाहेंगे ना आप कि आपका न्यूमरेटर मैक्सिमम हो, डिनोमिनेटर मिनिमम हो, तभी आपको ये टर्म है वो मैक्सिमम मिले. So to do that, usually अगर आपको कोई भी फंक्शन दिया जाता है, if you want to calculate the point of inflection or minimum or maximum with respect to any variable, what you do? You take its derivative with respect to that variable and put that equal to 0. So for that, that means what we can do is that I can take the derivative of this with respect to beta and put it equal to 0. And from there, I should be able to get the condition of minima and maxima. Right? This is how you calculate the point of inflection for any function with respect to any variable. Now, if we do that, if I take the derivation of this expression with respect to beta, I naught तो constant है, right? You can do the derivation with respect, you can do the derivation by parts. First, let's keep 1 upon beta square को आप constant रखिए. Sin square beta का अगर आप derivation लोगे, you will get 2 times sin beta cosine beta. Second time sin square beta, let's keep that constant. 1 upon beta square का अगर आप differentiation करोगे, -2 upon beta cube मिल जाएगा. Power आगे, power यहाँ पे आपकी -2 होगी and 1 power would be less. So this should be equal to 0 in that case. Now from here, what I can do is that 2 times I naught sin square beta upon beta cube को, ये वाली जो term है, सारी की सारी let's take it common. यहां से आपने 2 को बाहर निकाल दिया, बीटा क्यूब निकाला है, बट यहाँ तो आपके पास में सिर्फ बीटा स्क्वायर है, सो दैट मीन्स यू हैव टू मल्टीप्लाई बाय बीटा. यहाँ पे सिर्फ साइन बीटा है, आपने साइन स्क्वायर बीटा को बाहर निकाला है, सो दैट मीन्स यू हैव टू डिवाइड दिस फंक्शन बाय साइन बीटा. -1 इज इक्वल टू 0. From here, either you can say that this term is 0 or this term is 0, right? अगर ये वाली term 0 होती है, we get the previous condition, similar to the previous condition where you had sin square beta upon beta square, जो कि आपको minimum की condition देगा, and we have already discussed that particular scenario when your sin beta is equal to 0 and beta is not equal to 0. We have already discussed that condition and we did find out that this will basically give you the minimum if this is equal to 0. The second condition, second scenario is if this second term is equal to 0. That means we are saying that beta upon, I can write it as quote beta, or I can also write it as 1 upon tangent beta -1 is equal to 0. Or I can say that basically beta upon tangent beta is equal to 1. Or beta is equal to tangent beta. Whenever this condition is satisfied, you will get a maxima at that point. How do we find out when this condition will be satisfied? What you can do for these kind of equations is that, इसको अगर आप simply solve करना चाहें, that would be complicated, but what you can rather do is that you can say that I can plot the graphs. Tangent beta को plot करना बहुत आसान है, beta को plot करना बहुत आसान है. So what I can say that, let me define a variable y which is equal to beta and y is equal to tangent beta. Now I can plot the graph for both of them. This is beta and let's say this is y, right? You are very well familiar what these kind of graphs would look like. Y is equal to beta would be a straight line जो आपके origin के through pass होगी. Sorry about the poor drawing. So this is basically your y is equal to beta line. Y is equal to tangent beta. Tangent function कैसा दिखाई देगा? This is, let's say 0, this is pi, this is 2 pi, this is 3 pi, and so on. We know that tangent pi by 2 is equal to infinity, right? And tangent 0 is equal to 0. So tangent pi by 2 अगर आपका यहाँ कहीं आ रहा है, so this would go to infinity, and from here this would come something like this. This is basically y is equal to tangent beta. The second curve would come for the tangent beta. जब 3 pi by 2 होगा तो ये आपका फिर से infinity पे चला जाएगा, pi पे ये आपका 0 हो जाएगा, and then it would go something like this. 5 pi by 2 पे infinity हो जाएगा, 2 pi पे 0 हो जाएगा, and it would go something like this. And the points where both of these lines intersect each other, those points will be your solution to this equation, right? Let me repeat that. आपने ये दो ग्राफ plot किए, which were simple graph to plot, and wherever these two graphs will intersect each other, that means at those points your y is equal to beta and y is also equal to tangent beta, which basically means that this condition is being satisfied at these points. And where does this happen? When beta is equal to 0. Next, it would happen when beta is equal to 1.43 pi. Next, it would happen when beta is equal to 2.46 pi. So beta is equal to 0. We already discussed that case. That would give you a central maxima. Beta is equal to 1.43 pi. ये आपका फर्स्ट मैक्सिमा दे देगा. Beta 4.26 pi. This would give you a second maxima. इन पॉइंट्स पे इंटेंसिटी क्या होगी? Easy to calculate. I is equal to I naught sin square beta over beta square. बीटा की वैल्यू प्लग इन कर दीजिए. 1.43 पाई डिवाइडेड बाय 1.43 पाई होल स्क्वायर. ये आपकी फर्स्ट मैक्सिमा की इंटेंसिटी आ जाएगी. सेकेंड मैक्सिमा की इंटेंसिटी जब आप कैलकुलेट करो, बीटा की वैल्यू 2.46 प्लग इन कर दीजिए, आपको सेकेंड मैक्सिमा की इंटेंसिटी आपको मिल जाएगी. So this is how your graph is going to look like for the maxima, or this will be the conditions for maxima, and we already discussed the conditions for minima. I'll show you a figure now, or rather than an animation now, which can tell you how would the diffraction pattern look like. Can you see my screen? Diffraction of light by a single slit.
Yes, ma'am.
Okay, the link I have already provided on the PPTs also. So this basically gives you freedom to change the wavelength of light. आप light की जो wavelength है वो change कर सकते हो. And you can see the pattern here. ये आपका central maxima है जहाँ पे यहाँ दिखाई दिया है. And then this corresponds to your first minima, and these are your first maxima, and so on. Width of the slit, you can reduce the width of the slit. Uniform illumination आपको मिल रहा है. If you can increase the width of the slit, now look, आपका जो minima और maxima है, now you can see the larger number of maxima here. ये आपका central maxima है, first maxima, second maxima, third maxima, and so on. Keep on increasing the width of the slit, and you can see the effect here. Try the different wavelengths, try the different widths of the slit, and you can see how the diffraction pattern will vary as you change the ratio of wavelength and the width of the slit. वो decide करेगा आपका. Remember, in the diffraction we said that the size of the slit is kind of comparable to the size of the wavelength. आपका जिस size का wavelength होगा उसी size की आपकी slit होगी approximately. Try doing that at this website. The link has been provided in the PPT, which is uploaded there. So this was all about the single slit diffraction pattern. Now we'll move on to this double slit diffraction pattern.
Ma'am, can you show the first slide? Ma'am, the first slide of today's class.
Okay, this was something which was doubt from the previous class.
No, ma'am, the slide. No, ma'am, the next. Yeah. Thank you, ma'am.
Okay. Now let's talk about the double slit diffraction pattern. When I'm saying double slit, let me draw how do I expect it to look like. So you have a very thin slit, and we do assume that the width of the slit is very small and it is infinitely long slit. And then you have a second slit also. Both of these slits are of finite width, and that width, as we said that in the single slit diffraction pattern also, we said that this slit is the width of these slits is going to be B. So now also we are going to assume both of the slits, they are of the same size. दोनों slits हैं, उनका same size है, that means दोनों की जो width है वो B है. and they are being separated by this opaque thickness, and we are going to say that the thickness of this opaque material is A. So this is how the double slit image is going to look like. And when I'm going to draw it, so now I'm going to draw it this way. This is your slit 1. This is your slit 2. Width of both of the slits is same, which is B. Imagine these slits coming out of the screen and going up to infinity. So these are infinitely long slits. And this is the opaque material in between these slits, which is A here, which is basically this material here. We again have a plano-convex lens because we are talking about the Fraunhofer diffraction pattern, and both our screen as well as source has to be at infinite distance with respect to the slit here. Now, what do we expect at the screen here? What kind of pattern do we expect at the slit here? You have done Young's double slit interference pattern. You know what do you expect if these slits would have been point holes basically. But what would happen if rather than being point holes, these slits are slits of the finite size? In that case, on the screen, do you expect an interference pattern? Do you expect a diffraction pattern? Or do we expect a superposition of both of them? We'll see that, and I'll also prove that in the case when your slit size tends to 0, that means when your B tends to 0, in that case, whatever the intensity expression that we will derive, that would be basically equivalent to your Young's double slit interference pattern. So let's first start with the finite size of the slit, and let's say this is the point P, jahan pe you are trying to look at the interference pattern, and just assume this lens to be slightly bigger. These both of the slits, they are of the same size. So let's say that if I divided this single slit into n number of points, while talking about the single slit diffraction pattern, we can divide now both of the slits into n number of points here. Which basically means that A1 ke correspondingly you will have B1, A2 ke correspondingly you will have B2, A3 ke correspondingly you will have B3, and so on. For AN you will have point BN. A1 is at the top of the slit, B1 is also at the top of slit. So the distance between A1 to B1 is basically B plus A. So I can say that A1 to B1, the distance is basically A plus B, and let's define that as D. Which basically now I'm saying that the sum of these two terms is equal to D. Let's say यहाँ से आपकी light diffract हुई by an angle theta. Exactly by the same angle, इस वाले point से आपकी जो light है, that will be diffracted by angle theta here. Now, with respect to wavelets that are starting from A1, the wavelets that are starting from B1, they will travel some distance which is going to be extra. How we can calculate that distance? If I can draw a perpendicular from here to here, अगर मैंने यहाँ से यहाँ perpendicular draw कर दिया है, उसके बाद में both of these rays they are parallel to each other. तो उसके बाद में वो जितना भी distance travel करेंगे, that would be equal to each other. So the wavelets that are starting from point B1, they are going to travel this much distance extra. B1 prime basically. How much is this extra distance? We can do that calculation easily as we did in the single slit. If this angle is theta, this angle is going to be 90 minus theta. If this angle is 90 minus theta, that means this angle is going to be theta. Now in the triangle, let me change the color. In this triangle over here, which is a right angle triangle, B1 prime, which is perpendicular, upon a1 b1, which is hypotenuse, is equal to sine theta, which basically means that b1 b1 prime is equal to a1 b1 times sine theta, but a1 b1 is nothing a plus b or d. So b1 b1 prime is equal to d sine theta, which basically means that आपकी जो भी wavelet b1 से start होंगी with respect to a1, they have to travel this much distance extra. इतना path extra उनको travel करना पड़ेगा. Similar to this, you can talk about point A2 also. A2 से भी जो आपकी wavelet start होंगी, उसके वो भी थीटा सबटेंड करेंगे. A2 के correspondingly point B2 है, वहां से जो wavelet start होंगे, वो भी एंगल थीटा सबटेंड करोगे. यहां से अब आप चाहो तो A2 से B2 पे परपेंडिकुलर आप ड्रॉ कर सकते हो. B2 से जो wavelet extra travel distance करेंगी, that would be B2 prime. Again, the angle is theta same. यहां से जितना आप यहाँ पे नीचे एक्स्ट्रा डिस्टेंस ट्रेवल किया, उतना डिस्टेंस आपने यहाँ पे ट्रेवल कर दिया है. तो A2 B2 जो डिस्टेंस है, दैट इज आल्सो इक्वल टू A प्लस B और इक्वल टू D. वो भी आपका D के इक्वल है. तो B2 से जो वेवलेट स्टार्ट होंगे, वो जो एक्स्ट्रा डिस्टेंस ट्रेवल करेंगे, दैट इज आल्सो इक्वल टू D साइन थीटा. Similarly, AN के correspondingly, which is at the bottom of slit first, आपके पास BN point है, और वो वाला जो आपका BN point यहाँ पे है AN के correspondingly, again you can draw the lines here also. ये वाली यहाँ से जो wavelet start होंगी, वो कितना distance extra travel करेंगे? You can simply draw a perpendicular from here to here. परपेंडिकुलर ड्रॉ कर लीजिए. फिर से ये वाला जो एंगल है आपका, दिस एंगल would again be equal to theta, and bn prime अगर आप करोगे, you will find that bn prime is also equal to d sin theta, which basically means that for every single point on the first slit, there is a point on the second slit which is going to travel this much distance extra. वो इतना distance जो है वो extra travel करेगा. Now, how do we take this extra distance into account? By introducing some kind of phase constant, as we did in the case of single slit. We know that if your path difference is lambda, then the phase difference is going to be 2 pi. If your path difference 1 होगा, phase difference होगा आपका 2 pi by lambda. अगर आपका path difference d sin theta है, तो how much would be the phase difference? 2 pi by lambda into d sin theta. इतना जो है वो आपका phase difference होगा between the wavelets that are going to start from slit 1 and the wavelets that are going to start from the second slit. As I said before, we'll do the expression for the single slit. I'm going to pick up that expression and start for the double slit. And similarly for the n slit also, we'll not do the derivation for the single slit. वहां पे भी मैं single slit का derivation as it is borrow करके will move on from there. Now at this point P, आप क्या expect करोगे? इस स्लिट की वजह से जो आपका डायफ्रैक्शन की वजह से जो डिस्टर्बेंसेस आएंगे, प्लस इस स्लिट की वजह से आपके डायफ्रैक्शन की वजह से
Excuse me, ma'am.
हाँ जी.
Ma'am,
Hello?
your voice is lagging.
Okay. कुंदन प्लीज स्क्रीन शेयर अलाउ कर दीजिए. Kundan?
Your voice is not. Your voice is not clear.
Okay, I'm talking to co-host. Kundan, please मेरे को स्क्रीन शेयर की परमिशन दे दीजिए.
Ma'am, co-host left the meeting.
I am in the meeting, ma'am. Hello.
कुंदन स्क्रीन शेयर करने की परमिशन दे दीजिए.
Screen share की.
हाँ जी.
Please see it, ma'am.
It's saying to me that host has.
I think you can share.
No, I can't. Let me rejoin the meeting again.